day, everyone. Welcome to the new discussion. Our topic for today is all about the analysis, interpretation, and use of this data. So, our learning objectives are at the end of the lesson, the learner should be able to analyze, interpret, and use of this data when applying the definition analysis, interpretation, and statistics, the measures of central tendency, and the measures of variability. So let us hear now the first reporter, Mrs. Cherry May Angay.
Good day, everyone. I am your reporter for today. I am Cherry May Kabilaw Angay. Now we will be able to tackle about analysis and interpretation of data. So, as you can see, to our slides, that analysis and interpretation provide answers to the research questions postulated in the study. Analysis means the ordering, manipulating, and summarizing of data to obtain answers to research questions. Its purpose is to reduce data to intelligibly and interpretable form so that the relations of research problems can be studied and tested. So when we talk about interpretation, it gives the result of analysis, makes inferences pertinent to the research relation studied, and draws conclusions about this relation. So the next slide, we have here the statistics. Statistics is simply a tool in research. In fact, according to Alidi in 1974, statistic is language which, through its own special symbols and grammar, takes the numerical facts of life and translate them meaningfully. So statistic thus gathers numerical data. The variation of the data gathered are abstracted based on growth characteristics and combined to serve the purpose of descriptions, analysis, interpretation, and possible generalization. According to McGagan in 1987, and research, so this is known as the process of concatenation, where the statements are chained together with other statements. So there are two kinds of statistics. One is descriptive statistics. Descriptive statistics allows the researcher to describe the population or sample used in the study. The second statistics is the inferential statistics. Inferential statistics draws inferences from sample data and actually deals with answering the research questions postulated, which are in some cases cause and effect relationship. So in the descriptive statistics, it describes the characteristic of the population or the sample. To make them meaningful, they are grouped according to the following measures. 1. Measures of central tendency or averages. The second thing is measures of dispersion or variability. The third one is the measure of non-central location. The fourth is the measure of symmetry and or asymmetry. And the last one is the measure of peckiness or flatness. So let's talk about the measure of central tendency or averages. These include the mean, mode, and the median. So the mean is a measure obtained by adding all the values in a population or sample and dividing by the number of values that are added, according to Daniel in 1991. The mode is simply the most frequent scores of scores, according to Blalock 1972. Then the median is the value above and below which one half of the observation falls, according to Neurosis. Next is the measure of dispersion or variability. When we say about the measure of dispersion or variability, this includes the variance, standard deviation, and the range that is according to Daniel. A measure of dispersion conveys information regarding the amount of variability present in a set of ideas.
Good day everyone, my name is Gian G. Banawan and I will continue the discussion. So measures of central tendency. So the word measures of central tendency means the central location or a point of a set of values. So that means it is a single value that attempts to describe a set of data by identifying the central position within the set of a data. So there are three commonly used measure of central tendency: the mean, the median, and the mode. First, mean. So what is mean? So it is the most popular and well-known the measure of central tendency. So the mean is equal to the sum of all the values in the data divided by the number of the values of the data. So that means the sum of the value of each observation in the data set divided by the number of observation, also known as arithmetic average. So here are the example. So in a survey of 7 households, the number of children found to be. So we're going to add all the numbers here. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 equals 28. So divided by 10. So 28 divided by 10. So our mean is 2.8. Okay. So next we are here in median. It is the middle score of a set of data that has been arranged on order of magnitude. It is the value that split the database in half. So here are the example. In a survey of 7 households, so the number of children are found to be. So in order for us to find the median, so we put the data in numerical order. So 1, 2, 3, 4, 5, 6, 7. So our median here is 4 because it is the center of the numbers. Okay, it's the middle value in distribution. So next we have here now in mode. It is the easiest measure of central tendency to obtain if the score are arranged in a frequency distribution mode is estimated as the midpoint of the class interval which has the highest frequency in the set. So for example, here in the survey of 7 households, the number of students are found to be 5, 6, 4, 3, 2, 1, 7. Since the highest data is 7, so then our mode is 7. Okay? So what is the measurement of skill? It is a classification that describes the nature of information within the values assigned to variables. So there are 4 scales measurements that apply to treatment of test data. So first we have here the nominal scale measurement. This is used to categorize data into mutually exclusive categories or groups. So example, the gender, country, the player's t-shirt number. Respondents of the questionnaire can be divided into 2 categories. The males can be assigned number 1 and the females number 2. So the reason why it is the nominal, it is because we could have just easily assigned the female and the male. So it doesn't matter what the number we come up as long as the all male and the female are separated numbers. So next we have here the ordinary scale of measurement. It is used to measure the variables in a natural order, such as a rating or ranking. They provide the meaningful insights into attitudes, preference, and behaviors by understanding the order of responses. For example, here, how satisfied are you with our services? So we can put the totally satisfied, satisfied, neutral, and dissatisfied. So this all about the ratings there. So we can say that is an ordinary scale of measurement. So next we have here now in the third one, the interval scale of measurement. It contains properties of nominal and order data but the difference between the data points can be quantified. So this type of data shows both the order of the variables and the exact difference between the variables. So for example, so the measurement of temperatures and time. Okay, so the number have order like ordinal, but there are also equal intervals between the adjacent categories. So the scales is attained when the values can describe the magnitude of the difference between groups or when the interval between the numbers are equal. So that we call the interval scale of measurement. Next, the ratio scale of measurement. So the highest level of measurement, it carries the properties of nominal, ordinal, and interval scales. So data in the ratio scale can be added, subtracted, divided, and multiplied because of the existing of true zero value. So the ratio scale doesn't have negative values. So example, the weight and height and distance are all the example of precious variables. So what are mean, median, and mode appropriately used? So for a nominal level, you can only use the mode to find the most frequent value. So for an ordinal level or ranked data, you can also use the median to find the value in the middle of your data set. So for an interval or the ratio level, in addition to the mode and median, you can use the mean to find the average value. How do measure of central tendency to determine the skewness? So the mean, median, and mode in symmetrical distribution. If a frequency distribution graph has symmetrical frequency curve, then the mean, median, and mode will be equal. So that means the mean, median, and mode have the same value. Okay, so have the same frequency distribution of value. So that we call the symmetrical distribution. Next, the mean, median, and mode in positively skewed distribution. So the mean is always greater than the median, and the median is always greater than the mode. Okay, so that means the mode is magiging mababa siya. Magiging mababa ang value niya kasi nandun ang negative directions. Okay. Ang negative direction ay nasa left side natin. So, ang mean dito is magiging mataas ang kanyang value kasi nandun siya sa positive direction. So, the right side is a positive direction. So, our median between the mode and the mean. Okay, so next, the mean, median, and the mode in negatively skewed distribution. So the mode is more than the mean and the median. On the left side, there are few values. So that means ang curve niya ay nasa negative direction. Okay? So ang mode dito ang pinakamataas na value kasi nandun siya sa positive direction. Ang mean naman dito ang pinakamababang value kasi nandun siya sa loss curve kahit nasa positive direction siya. Okay? So that's all my report. So God bless and have a nice day ahead. Let us hear now the third reporter, Norhana Banglan.
Kolmogorov-Smirnov test fulfills the function of chi-square in testing goodness of fit, and of the Wilcoxon rank sum test in determining whether random samples are from the same population. Kolmogorov-Smirnov test is a statistical test used to determine whether a sample comes from a specific probability distribution or whether two samples come from the same population. It is a non-parametric test, meaning it does not make any assumptions about the underlying distribution of the data. The Kolmogorov-Smirnov test can be used in the two main ways. One sample of the Kolmogorov-Smirnov test is this test compares a single sample to a reference probability distribution. It determines whether the sample follows the same distribution as the reference distribution. The test calculates the maximum absolute difference between the empirical cumulative distribution function of the reference distribution. If the calculated test statistics exceeds a critical value, it suggests that the sample does not come from the reference distribution. And the second sample is this test compares two independent samples to determine whether they come from the same population or having significantly different distributions. It calculates the maximum absolute difference between the empirical cumulative distribution function of the two samples. If the test statistic exceeds a critical value, it indicates that the two samples are likely to come from different populations. The Kolmogorov-Smirnov test is often used when the assumptions of the other tests, such as the chi-square test for goodness of fit or the Wilcoxon rank sum test, are not met. It is particularly useful for testing the goodness of fit of a sample to a distribution or comparing two samples when the distribution are unknown or not assumed to be normal. Sign test is important is determining the significance of differences between two correlated samples. The signs of the test are the algebraic plus or minus values of differences of the paired scores. The sign test is a statistical method used to test for consistent differences between pairs of observations. It is commonly used when comparing the differences between two correlated samples, such as the weight of subjects before and after treatment. The test determines if one member of the pair tends to be greater than the other. The sign test is a non-parametric or distribution-free test, which means it does not assume a particular distribution for the data. Instead, it compares the sizes of the two groups based on the direction of the plus or minus signs of their observations. Median test is a sign test for two independent samples and contradistinctions to two correlated samples, as is the case with the sign test. The median test, also known as Mode's median test, is a non-parametric statistical test used to compare the medians of two or more independent samples. It is a special case of Pearson's chi-square test. The test aims to determine whether the medians of the populations from which the samples are drawn are identical or significantly different. It is particularly used when the data is not normally distributed or when the sample sizes are small. To perform the median test, the following are typically followed. Combine the data from the two or more independent samples. Second, calculate the median of the combined data. And the third, divide the combined data into two groups based on whether the values are above or below the median. Fourth, count the number of observations in each group for each sample. Fifth, use a chi-square test to compare the observation frequencies in each group with the expected frequency under the assumption of equal medians. And lastly is, if the test statistic is significant, it indicates that the medians of the samples are significantly different. It is important to note that the median test is a non-parametric test, meaning it does not make assumptions about the underlying distributions of the data. Spearman rank order correlation, sometimes called Spearman RHO or Spearman rank difference correlation, is a nonparametric statistic that has its counterpart in parametric calculations in the person-product moment correlation. The Spearman rank order correlation, also known as Spearman's or Spearman's rank difference correlation, is a nonparametric statistical measure that assists the strength and direction of the relationship between two variables. It is a counterpart to the parametric person-product moment correlation. Crousall-Wallace, sometimes also known as the Crousall-Wallace H test of ranks for key independent samples. The H is the title of the test and stands for the null hypothesis, and the K for the classes or samples. The Crousall-Wallace test is used to determine whether there is a statistically significant difference between the medians of the independent groups. It is a particularly useful when the normality assumptions is violated or when the data is not normally distributed. Kendall coefficient of concordance is also known as Kendall's coefficient W or the concordance coefficient of W. It is a technique which can be used with advantage in studies involving rankings made by independent judges. The Kendall's coefficient of concordance is also known as Kendall's coefficient W or the concordance coefficient of W. It is a statistical measure used to assess the level of agreement or concordance among multiple judges or raters when ranking or rating a set of items or subjects. Mann-Whitney-Otis in nonparametric statistics is the counterpart of the t-test in parametric measurement. It may find use in determining whether the medians of the two independent samples differ from each other to a significant degree. The Mann-Whitney-Otis is especially useful when the data does not meet the assumptions of normality or when the data is measured on an ordinal scale. Wilcoxon match pairs sign rank test is employed to determine whether two samples differ from each other to a significant degree when there is a relationship between the samples. The Wilcoxon sign rank test is used when there is a relationship between the samples, meaning that the two samples are paired or matched in some way. For example, the samples could be measurements taken before and after treatment on the same group of individuals, or measurements from the same individual under different conditions. Wilcoxon rank sum test may be used in those non-parametric situations where measures are expressed as rank data in order to test the hypothesis that the samples are from a common population whose distribution of the measures is the same as that of the samples. The Wilcoxon rank sum test, also known as the Mann-Whitney-Otis, is a non-parametric statistical test used to compare two independent samples. It is commonly used when the data is not normally distributed or when the data is measured on an ordinal or interval scale and cannot be assumed to follow a specific distribution. The test is used to determine whether there is a significant difference between the distributions of the two samples. It tests the null hypothesis that the samples are from a common population with the same distribution of measures. The alternative hypothesis is that the distribution of the two samples are different. To perform the Wilkinson rank sum test, the data from both samples are combined and ranked in ascending order. The ranks are then assigned to the observations, with ties given the average rank. The sum of the ranks for each sample is calculated. The test statistic U is obtained by comparing the sums of the ranks. The test statistic U can be used to calculate the p-value, which indicates the probability of obtaining the observed difference, or a more extreme difference between the two samples if the null hypothesis is true. If the p-value is less than a predetermined significance level, commonly 0.05, the null hypothesis is rejected, and it can be concluded that there is a significant difference between the distributions of the two samples.
So that's all of our reports. So thank you for listening and watching, and God bless.